Hello all, welcome to this course on Elements of Mechanical Engineering. My name is Atchuta Ramacharyulu and I am working as an assistant professor in the Department of Mechanical Engineering. We are in the third module of this course, Elements of Mechanical Engineering, where we are studying different engineering materials and joining processes. Now in this lecture, we are going to see what are the different joining processes. In the previous lectures, we have seen what are the different materials, engineering materials, metallic, non-metallic, and different types of plastic, ceramics, conductors, semiconductors, insulators, etc. We have seen many materials. Now, let us try to understand how these materials or metals join. Now, what is a joining process? We should know what is a joining process. So, we are, as a mechanical engineering related course, we are going to study the joining of metals. Only joining of different types of metals are used. Depending on the size, thickness, different techniques are used for different metals. So in that, we have three main methods. So the first one is soldering. And then we have brazing. And then we have welding. There are three methods which are widely used in manufacturing industry. So any manufacturing industry will have these three methods. Mostly the soldering and brazing methods are less used compared to welding. So all these three techniques will be used to join two metals. The joint that is formed by these techniques are permanent and they are stronger, as strong as the base metal. Now let us try to see what is each method will define. How each method will work and their applications. Now let us see the first one, soldering. So soldering is a joining process which is used for very weak joints. Okay. In soldering, the filler metal melts at a relatively low temperature. We should know what is a filler metal. So filler metal is a metal which is used to join the two base metals. Like I will take the example in welding so that it is very easy to understand. So if I have two plates, if I want to join these two plates at this area, these two plates has to be joined together. I will place these two plates together and I will weld. Okay. While welding, I have to use some meltable metal rod. So this meltable metal rod, upon heating, it will melt and it will form a layer between these two. It will form a layer like this. So this entire thing will form a joint. Okay, the two plates are joined together. Now, this meltable filler material, it is very key point because meltable rod is called as filler rod. Without this filler rod, welding is not possible. Even soldering and brazing also. The joining process is not possible without a filler rod. So the filler rod is a meltable material which is used in the joining process where it can melt by the heat and it will form a joint between the two bodies. Now, this filler rod will melt at lower temperature in this soldering process. So that is why it is called soldering technique. Two important characteristics of solders are low surface tension and high wetting capability. So soldering is generally used for objects that are very small like electronic circuits or electronic printed circuit boards will be welded. The small capacitors and all will be welded with the help of soldering. Okay. So this soldering, because it is forming a very weak joint, we have to see that the solder material should have low surface tension and high wetting capability. Okay. These are the two characteristics that are required for a soldering material. Now let us see what are the different types of solders and fluxes. Okay. Solder melts at very low temperature when compared to welding. As we know, we don't know what is welding is as of now. We'll learn in the coming stages. And the example for solder material is tin lead solder, which melts at 188 degrees centigrade, which is far lesser than iron. Now let us see types of solders and their applications. So first one is tin lead solder, which is general purpose. That means it is used for circuit boards. All circuit boards are prepared or soldered with the help of this material. And then we have lead silver, where strength at higher than room temperature. So at room temperature, this lead silver has more strength when compared to tin lead. And then we have cadmium silver. This is another solder material where strength at higher temperatures is more. Okay. And zinc aluminum. Because why do we need this strength at high temperature? Because the circuit boards which are soldered will heat when they are being used. So even at higher temperatures, the soldering should not lose. Okay, the soldering should be as strong as at room temperature. Because working at high temperature, the solders may disconnect the entire circuit from the body. So that is why the solders should be as strong as possible. And then we have tin silver solder, which is used in electronics. Tin bismuth is also used in electronics. So these are some of the solder materials which are used in the electronic industry as well as for soldering. So let us see what is solderability and how it affects the soldering process. Solderability may be defined as the capacity to be soldered into a specific structure which needs the requirement. So if I take a example of a circuit, the circuit should be having the property of solderability. That means it can be able to, a person could be able to solder different joints by using a solder material. Okay, so that property is called solderability. That means I could be able to solder it by using a soldering technique. Then I can call it as a solderability property. Now, special fluxes have been developed to improve the solderability of metals and alloys, which are like copper, silver, and gold are easy to solder. So these are the metals which can be easily soldered. And then we have iron and nickel are more difficult to solder. So when we compare, copper, silver, and gold are having more solderability property than iron, nickel, etc. Aluminum and stainless steel are difficult to solder because of their thin, strong oxide films. So aluminum and stainless steels, they have a thin oxide films where they will not form solderability easily. Okay, and then we have steels, cast irons, titanium, and magnesium, as well as ceramics and graphites can be soldered by first planting them with suitable metallic elements to induce interfacial bonding. So steel, cast irons, and titanium, magnesium, etc. These are all metals can be welded with a proper technique. Like they can be welded, they can be soldered by applying a pre-coat. We have to apply a coat on them so that soldering can be done, because they are not so solderable. Okay, tin plate in a common material used in making cans for food. So this tin plate, which is used for canning foods, like foods are stored in the cans, like thumbs up cans. So these are soldered with the help of soldering technique. So let us see some soldering techniques. There are multiple soldering techniques are there depending on the application. So the first one is torch soldering, where we will use a torch for the soldering process. And then we have furnace soldering, where we will keep the entire thing in a furnace and we will solder. So, and then we have iron soldering with the use of soldering iron. We will use iron for this process. And then we have induction soldering, resistance soldering, dip soldering, infrared soldering, ultrasonic soldering, reflow, and wave soldering. So depending on the type of heat source we are using here, we have different name for each type of solderings. Okay, in this we will use a torch for heating the solder. Here we will use furnace. Here we have iron soldering, induction, resistance, dip soldering, infrared. So infrared is being used for heating the solder metal. Ultrasonic sound is used to heat reflow and wave soldering. So these are the different techniques used for heating the solder metal so that it will form a layer on the structure. And then let us see applications of soldering. So soldering is used extensively in all electronics industry because it will form a very weak joint. So it is very suitable for very small joints that are formed on a electronic device board. Soldering temperatures are relatively low. A soldered joint has very limited utility at elevated temperatures. This is also very important because at elevated temperatures, a soldered joint may not withstand. It will easily break off. So these are the applications of soldering techniques. And then we have different types of joints that can be formed in soldering. So this one is flanged. So the arrangement is like this. And then we have flush slab. So one plate is placed on the other. And then we have flanged corner. So two plates can be cornered and joined. And then we have line contact where a semicircular plate is placed over a flat plate to be joined. And then we have flat lock seam. And then we have flanged bottom combinations. So this flanged bottom is the structure, or it is a joint which is used in the preparation of cans. So on the drink cans and food cans, they are made using this flanged bottom. The bottom plate is flanged with this solder. And then we have combination joint. We have through hole connection, crimpled combination joint, twisted wire joint, etc. So these are all the different types of joints which are used for soldering technique. And then let us see what is brazing. Now so far we have seen soldering technique, which is having a very low melting temperature for the solder. So it is used for making very weak joints. Okay. Only it can be used for electronic devices like electronic circuit boards can be soldered. Now brazing is the second process. It is also a joining process where two objects can be joined with the help of this brazing by using a technique called, by using some other metal that is called filler metal. So this filler metal can be joined with the help of this brazing technique. Okay, so brazing is a joining process in which a filler metal is placed between the faying surfaces to be joined, and the temperature is raised sufficiently to melt the filler metal, but not the components as would be in the case of fusion welding. Now observe carefully here. We should know what is fusion welding first. So fusion welding is nothing but heating the base plates also. So if I want to join two plates, suppose if I take this joint, I want to form a joint here. I want to make a brace here. So I will heat, in fusion welding, I will heat the two objects. Like I will heat the bottom plate and I will heat this rod, metallic rod. So I will heat both of them along with a filler rod and I will form a joint. But in brazing, what happens? I will melt only the brazing filler rod. Only the filler rod will be heated and it will form a layer. So which indicates that the joint formed here is somewhat weaker than welding. Okay, because we are not heating the actual body. Whatever the two plates we are trying to join, we are not heating the two plates. We are just melting the filler rod to form a joint. So because of this, the actual joint is weaker than the welding. So these are the different types of joints which can be formed by using the technique called brazing. And the temperature is raised sufficiently to melt the filler metal only, but not the components. This is the key point to be noted. And then we have different types of filler metals that are used for brazing technique. So they are aluminum and its alloys. Okay. So for all aluminum and its alloy as base metal, we should prefer aluminum silicon. So the filler material selection is shown in this table. So for this base metal, this is all base metals, and then we have filler metals. So depending on the base metal, we have to choose particular filler metal. Okay. So for aluminum, we have to choose aluminum silicon, and its brazing temperature is about 570 to 620. And then for magnesium alloys, we have to choose magnesium aluminum alloys where the temperatures are 580 to 625 degrees centigrade. And then for copper and its alloys, we should select copper and phosphorus where the temperature is 700 to 925 degrees centigrade. So depending on, suppose the base metal is aluminum, we have to choose a filler metal that is made up of, some components of it are made up of aluminum, but not other metal like copper, phosphorus. Okay, if we are using aluminum, should go for some elements that contain aluminum. Okay, if it contains magnesium, we should go for magnesium's aluminum. If it contains copper, we should go copper phosphorus. If it contains ferrous, iron related, we should go for copper based or phosphorus alloys. Okay, if it contains iron, we should go for nickel. Like iron, we should go for gold. If it contains stainless steel, we should, here nickel is there, nickel silver can be used. So if the base metal is iron, we should weld the brazing with the same material only, maybe combined with some other metal so that it improves the properties. Now, suppose I am welding a iron plate. I have to use a iron filler rod mixed with some other metal like magnesium or silicon. Why this extra material is added? It will improve the property. Like when I am making a joint, I have to melt this metal and I have to form a layer. So while forming this layer, because it has been melted so that it is converted into liquid form, it should be not losing its actual properties. So in order to protect the actual properties of the base metal that is present in the filler rod, we are adding some other metals like magnesium. Because while heating, the iron may lose its property. Some of its properties may be lost. So those properties will be covered by magnesium. So that is why all of them will have a separate metal that is added in addition to the base metal. Okay, this is how different brazing filler metals are used. And then we have fluxes. Now we should know what is a flux. So flux is a metal or it is a material essential in brazing. A flux prevents oxidation and remove oxide films. So when we are trying to form a joint, we will melt the metal and we will pour on it. Like we will melt the filler rod at the particular instance. So when the metal is heated, it will be converted into liquid form where it will be come in contact with atmospheric oxygen. So whenever the oxygen happens, what will happen? The joint will be weakened. Okay, the joint that is formed will be weak. So that is why we have to do a covering of this area by using the flux that is essential in brazing. So flux is a thing that prevents oxidation and removes oxide films. So brazing fluxes are generally made up of borax, boric acid, borates, fluorides and chlorides. So these are all the different borax or boric acids. These are all the fluxes which are used in brazing techniques. And wetting agents may be added to improve both the wetting characteristics of the molten filler metal and the capillary action. So wetting agents also can be used. So these are the agents which are applied on the freshly made joint to improve the capillarity action. That means the molten metal will flow easily throughout the joint. Now we'll see what are the different brazing methods. So the first one is torch brazing. So the heat source in torch brazing is oxy-fuel gas. We will use oxygen combined with some other gas like acetylene. So the combination will give the heat that is required for the brazing technique. Okay, where we will get carbrazing flame. Brazing is performed by heating the joint with the torch and then depositing the brazing rod or wire in the joint. Okay, we'll simply heat the filler metal with the heat that is coming out of the oxy-fuel torch, and we will make a joint. This is suitable part thickness are typically in the range of 0.25 to 6 mm. Torch brazing is difficult to control and required skilled labor. So torch brazing is very hard. it requires a skill. Okay, it is suitable for part thickness, typically ranges between 0.25 to 6 mm. Okay, if the thickness is between this limit, we can go for torch brazing. And then we have furnace brazing. So furnace brazing is first cleaned, the part is first cleaned, loaded into the furnace, and then the objects will be, I will explain. If two plates are to be brazed. So these two plates are kept side by side, and at the junction, we will place the filler metal. This entire thing is placed on a plate, and this plate is kept inside a furnace. So the furnace, when it is heated, all the things will be heated, like the filler metal, base metal, everything will be heated, and a joint is formed. Like it is very similar to a cooking in the oven. We will prepare everything and we will put in the oven so that it will prepare by heating. So this is very similar to this is how furnace brazing is done. And then we have induction brazing. So induction brazing, the source of heating here is induction by high frequency AC current. So we will use this high frequency AC current for producing heat, which will melt the filler rod and it will form a layer. And then we have resistance brazing. So in resistance brazing, the source of heat is electrical resistance of the components to be brazed, and electrodes are utilized in this method as they are resistance welding parts, typically with a thickness of 0.1 to 12 mm. So if the thickness is between these 0.1 and 12 mm, we should always go for resistance welding. So what is resistance welding? Resistance welding is a type of welding where the two metal plates are welded by using electricity. We have to connect electrodes to the plates, where electricity, when it is passing through the plates, they will be having some resistance to the flow. Because of this resistance, the plates will be heated. So due to this heat, the joint can be formed. So this is called resistance brazing. And then we have dip brazing. So let us see what is dip brazing. So dip brazing is carried out by dipping the assembly to the brazed into either molten filler metal or bath or a molten salt bath at temperature just above the melting point of the filler metal, for usually less than 5 mm thickness in diameter. So in this, what happens is, we will have a container where filler metal is there. This filler metal is heated. This is very hot, like it is heated up to its melting point. And then the two metal plates which are to be joined, they are kept in this. Simply a joint is formed. Or it is placed under a bath of the filler metal. So hot filler metal is being poured on this, so they will form a joint. Okay, so this is dip brazing. And then we have infrared brazing. Here the source of heating is infrared, high intensity quartz lamp. High intensity quartz lamp is used in this process for heating the filler metal. The process is particularly suitable for brazing very thin components, usually less than 1 mm thickness. So because the high intensity quartz lamp may not create so much temperature, so that it cannot weld objects of very high thickness. And then diffusion brazing. So diffusion brazing is carried out in a furnace where the proper control of temperature and time, the filler metal diffuses into fraying surfaces of the components to be joined. The brazing time required maybe ranges from 30 minutes to 24 hours. So the diffusion brazing is very similar to the furnace brazing, where the entire things, the two plates and the filler material, will be kept inside a furnace and they will be heated slowly. So the time will take from 30 minutes to 24 hours. So this is slowly done, yet it forms a brazing joint. Okay. So why this technique is required means, depending on the particular application, so diffusion brazing is required. And so far we have studied two techniques. That is, these are the two joining processes required in manufacturing industry. One is soldering, where we will use different types of soldering materials and fluxes for joining very weak joints, where the temperature of melting the filler rod is very low in this when compared to welding. And then we have a second technique called brazing, where the brazing technique uses a filler rod which is made up of different types. Depending on the type of base metal, we will use different types of filler rods. So this brazing technique will implement a stronger joint than soldering, but still a weaker joint than welding. So when we compare the joint strengths, so soldering is very weak, this is weak, this is strong, this is stronger. So depending on the type of application, we will select a particular technique. Okay, soldering, brazing, welding. Soldering is weak, brazing is strong, and welding is stronger than all the joints. So in the coming lectures, we are going to see what are the welding techniques and how these welding techniques are used in the engineering industry to form multiple structures. Big structures are made up of this welding only. Okay, that is all for this lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.